Welcome to another video where I work on my programming language Plum. I was wondering, you can't call lambdas with 0 arguments, which is kind of unfortunate. So you can define lambdas like this, but if you do something like this, foo doesn't take anything and just returns 42, I don't know. You can't call that lambda, because calls just use spaces, like make list of 3. But if there are no arguments, like this will fail to compile, I believe, because it will say that the main function returns a function from int to int instead of an integer. Yeah, so the main function returns the lambda returning an int instead of an int. And well, the syntax of this is actually inspired by ML and Haskell and so on. And these languages are lazy, which means that there is no lambda that accepts no arguments. Every expression is basically a lambda. If you just write 42 in your code, that 42 is not even like guaranteed to be evaluated. You can write crash something in your code and that is totally fine. And the code continues executing as long as that crash is never, as long as the value of that is never needed. Of course, that means that these languages are also quite complicated, because now you need to have additional logic, or like when does the value actually need to be computed? Like basically when do we evaluate things? You have to have rules for that. So for Plum, I'm totally fine with having laziness not in the language, but instead being required to have lambdas like that. You might wonder, like, what is the benefit of having a lambda that takes no arguments versus just specifying the value directly? And the thing is, there can be a difference if the value is expensive to compute, or if this thing right here crashes, or like stuff like that. I think for iterators that's actually really important, because for iterators you don't want to give any information to the lambda or whatever. You just want to say, give me another item, please, give me another item, and you want to be able to call that repeatedly without passing in any information, but getting stuff back. And I do want to support iterators and also infinite and iterators, so I need some sort of way of executing lambdas that have 0 arguments. Yeah, again, this is not a common pattern in Plum, because functions can't have side effects apart from crashing and halting endlessly. So while this is useful in rare cases, in most of the code you don't see anything like this. And so I'm fine with this being a bit clunky. Calling a lambda with no arguments is not the most common, the most important thing. So I was thinking, how about like a built-in call function? Really simple. Call takes a lambda that takes no arguments and produces something, and call just calls that lambda. Yeah, so let's do that. Let's say we have some sort of call function, and the core, the standard library, actually exports, let's see, some sort of call function that takes a lambda that takes nothing and produces some t. Yeah, and let's define that in the core module as well. So I'm actually not sure where that will go. I mean, it's not related to bools or bytes or hashing or ints or lists or maybe or never or nothing or ordering or result or string type. So I guess let's add a new module for that, which would be, I don't know, lambda. Call. Yeah, let's use call. how do other built-ins work? Oh yeah, there's the magic built-ins module that contains the built-in functions. So I want to do something similar here. Indent with 2 spaces, please. Built-ins. And in the built-ins package, there should be a call function that accepts a lambda, takes nothing, and returns a t. And well, yeah, that's also exactly what we are going to export. Simple. I think we should be able to put those on a single line, actually. And then in here we can say, yeah, we have the bool stuff. Now we also have the call stuff, and we import the call function, and then we export that down here. Okay, yeah. This will hopefully tell us something like, oh, there is no call function in the built-ins module, something like that. Yeah. So let's change that. How do built-ins work? I'm actually not entirely sure. But I believe that, look at that, there's a built-ins module. Yeah. Okay, we have byte operations in the future, int operations, maybe lambda operations, which will just be call. After compare ints, we'll have built-in dot call. Yeah. Okay, what is the signature of that? Well, it will actually take only a single argument, a lambda, so a plum type dot lambda of a lambda type, I think. Not entirely sure. Yeah. Yeah, that's kind of messy. Yeah, let's look in the type module. Lambda type has arguments, and it has a return type. Okay, so this has args, which is an empty slice of plum types. And it has a return type, which will be this t. Let's maybe put that over there, clean this up a bit, put an equal sign here. Yeah, now we're talking. Okay, let's see. So this call function, this is the list of arguments. It takes a single argument, which is a lambda that accepts no arguments and returns a t. And then that call function returns the t because it executes the lambda. And that looks reasonable so far. All right. Let's see where this fails next. Our return type is supposed to be an ampersand type. Sure. So we put that on the heap. So egg to yogurt. Yeah, in here, if we encounter a call, yeah, we don't actually want to have a yogurt built in, but we will just have a call. We'll just do that. How is that used? Oh yeah, down here, I see. Yeah, we'll just have a call. I'm wondering, oh yeah, we have args here. I see. So I guess args.0 would be the argument, the lambda. call that with no actual arguments. I think IDs. Yeah. Something like that. If we encounter a call, then instead of lowering to a yogurt call of a yogurt built-in stuff, we just directly compile to a call. So this built-in isn't actually triggering some built-in functionality, it's just becomes a call directly. Expected a closing brace. Let's see. We have a call right here. Okay. Oh, I see. The call needs named things like this. Yeah, this is supposed to return a result, so we need to write that in an OK. Sure, we can do that. And now the main function should just return 42. And oh, look at that. Okay, so we've computed the egg. We have not yet computed the yogurt. And let's maybe print the egg. Egg. Print, please. And let's see if that is correct. Oh yeah, the egg contains every single function, so that is quite a bit of code. Well, let's see. Where's the main function? Main of int. Yeah. We call the call built-in. Fair enough. Oh, hang on. Here we have substitutions. What do we do with those? In the egg to yogurt. Yeah. Hang on, let's look at the yogurt maybe. Okay, so here we have the operations. We have a call, yeah, and the callee can be one of these. Can be a lambda, can be a function, can be a built-in. I'm wondering though, what do we do with the substitutions? Where do we deal with those? Oh, I see. We do that in the built-ins, in the conversion from yogurt egg to yogurt, I believe. Hang on, in the egg. Oh yeah, the egg callee is either a lambda or a function or a built-in. And the function is actually a matching function with a string and substitution. I think we need to do the same for built-ins because we need to store the kind of substitutions. Yeah. So basically we figure out, oh, we call the call function that takes lambda. At that point in time we need to figure out that t has to be int. So the matching built-in will actually just be a built-in and substitutions. Yeah. And then later on in the egg to yogurt, exactly in the call, if we have a function, oh look at that, we have these merged substitutions. I think we'll do something similar here, merged substitutions. Right. This is the matching built-in. where's this type coming from? Large substitution. Yeah, I think that is... Maybe that's it. But we don't do anything with them, you know? I'm not sure how that's gonna work out. 3, 4, 8 in compile fun. Yeah, matching built-in of this built-in with the substitutions, which are hopefully in scope. Yeah. Ooh, all right, now those can't be printed, of course. So in the egg, we'll also need to have some sort of write function for the matching built-in. Hang on. Writing an expression. Oh yeah, here. Yeah, here we'll just write the built-in with the built-in substitutions. Yeah. True. Still won't compile, but I'm wondering where the error occurs. Yeah. So basically we compile the main function, so we compile the body, we compile the expression, the call expression, Let me maybe check that the lambda makes sense before doing that. So in the main function, right here we have a lambda that takes no arguments, produces an int. And we call the call function with t equals int. And the lambda is the argument. Fair enough. Oh, I see, that produces a t. That is not quite what we want. How's the type for that? Alright. Now we have a call. Oh, is that part of the compile fun of this bit? Yeah, the return type is not correct. In the case of a function, we just say, we take the function return type, we compile that, and we specialize that. In case of a built-in, we have the return type right here, and we should specialize that. Oh, seems like that worked. Yeah, this is the egg, okay. I'm interested in the yogurt, maybe. Or rather, even better, let me just call this, okay, yeah, and it returns 42 in hexadecimal. Alright, yeah, which means, yeah, things work. We can now call built-ins. We can now call lambdas that take no arguments, even though that's not generally, syntactically possible. We now have this call function from the standard library that we can use to do that explicitly. Okay, yeah, I guess I'm happy with that. That's it for this video, and yeah, see you in the next one.